Everyone, my name's Paul Ruiz, and I'm here to talk to you about STEM and how it relates to my job. STEM, we'll briefly go over, is science, technology, engineering, and mathematics. Now, you may be thinking, how do these elements apply to my everyday life? Or how do these apply to, say, a working environment? Like, if I'm a scientist, is science the only thing that applies to me? Or do I have to be a mathematician or an accountant for mathematics to count in my work? Well, that's not always the case. Now, my job is information systems technology, so I guess that kind of knocks out one of the elements, right? So you may think, well, yeah, of course, all those elements fit into it, but how exactly do they? Well, I'm going to explain a little bit how it all works. So I manage the local branch health clinic here in Sasebo, Japan. I manage a number of computers, help all the users out, all the providers, the corpsmen, and I make sure they have technological needs and tools to get their job done, which can be tough sometimes. So let's get into some of the elements. I'm going to start off with science. Okay, so let's say that you are the IT administrator of this small network. You got about 20 computers, a few network equipment, and a few servers. So don't really worry about that. It just looks like a big web. So one of your users tells you that they think they might have downloaded a virus and they're not sure how. So let's consider what exactly might have happened. So I'm going to task you with trying to help me figure out what's going on. So let's use the scientific method on how this might have happened. Now, here is a basic string of how the scientific method we might use it. There might be some steps missing here, like research, or maybe it might be arranged a certain way, but let's just use this for an example. So let's first observe what exactly happened. So we know there's a virus, someone associated with it, let's just say the user, and we need to know how. So let's ask them, for example, okay, so how do you think this might have happened? Let's put that under the question. So how did this happen? Why did this happen? And what we can do to prevent it. So first, let's talk to the user. So they just came back to you and they told you, well, I was going through my emails and I saw an email I thought was from one of our coworkers, but it turns out it wasn't. And they accidentally clicked on the link and the attachment. So that's already setting off some warning flags. And you might be thinking, how can something as simple as that be bad? Well, let's just say we'll add some research right here, right? Turns out stuff like that is the easiest way for a computer or network to get compromised. This is called phishing, not fishing for fish, spelled like this, with the P and H. So basically, phishing is what hackers use to trick people into getting into their computer or making them download something that they shouldn't be downloading. And by doing so can cause a lot of headache for the IT staff. But let's just create a hypothesis. So let's say, okay, well, based on this information, let's just say we think the virus came from this email. So it came from an email and the attachment. So generally, as a cybersecurity professional or IT person, you might want to experiment or see just how this might have happened. So maybe we have tools or a separate computer we can use to open the attachment and see just what's on there. Now, in an experimental environment, you don't want to be doing this on the network. You want to take that computer off the network so it's in a testing lab environment. So that way, no other computer can get compromised. That's actually one of the first steps you want to do when you first discover a virus is take that computer off the network immediately before it might have been too late. So let's just say we did the experiment and turns out the virus was from that attachment. Well, okay, let's make our conclusion then. So, the virus came from an email. So, what's the results? What can we get from this? Well, maybe we can start training people more. Maybe we can start creating more awareness and kind of telling people, like, look, this is more common than you think. And I can't spell right now. Here we go. So, let's try to do that in the future. Let's tell everyone, like, look, don't click on an email that might not be who you think it is. Just double check before you start clicking on links or attachments. Let's think about technology for a sec. Now, obviously, this is a really important part of my job because I need to know about the latest technology tips, stuff on servers, computers, everything that comes out. So I know I can stay up to date on what's going on. I have to consider how I can apply these to our current working environment and how it can benefit the staff. For example, maybe it can be something like, um, you know, a better hard drive. So, like old hard drives used to run on like spinning disks, right? And then it would burn on it. So those were pretty common, but now we have something called solid state drives. So those are way more efficient. Maybe if you're a gamer, you might have heard of it, but they're way more efficient and it significantly decreases loading times for computers. This is something that can benefit my staff because, hey, now they can get their computers working faster. Even though they might complain anyway that it's slow anyway, but it's okay. I'll take it. All right, let's go little bit into engineering. So let's take your smartphone, for example. What inside your smartphone makes it work? Well, it is engineered that way to make it usable, built upon an operating system so it's user friendly. This kind of goes hand in hand a little bit with technology, depending on what you're working with. So let me go back to my job, for example. So scripting, right? This is something like writing lines of code that can create automated functions. So let's say I need to install Google Chrome on a bunch of computers. Now, instead of logging into every computer and installing Google Chrome, I can create a function using my admin credentials to install Google Chrome on all the computers. Now, sometimes there are programs that can do this, but depending on what environment you're working with, you might have to do this manually due to certain cybersecurity elements that might be on your network. So, using creativity and knowing how to engineer it can help you in the long run for just about any job. All right, let's go real quick into mathematics. Now, I want to talk a little bit about IP addresses, for example. And I'm not going to get too much into this, but I just want you to wrap your head around this real quick. So, every device on the network or in the world that's connected to the internet has an IP address. Think of this like your house address or a mailing address. This is how we send mail to each other, right? We all have addresses. Well, IP address is how different devices communicate to each other and how they send data and information. Now, through these addresses, there's different ports. Think of them like doors. So maybe this door is specific for websites, the other door is specific for email, and so on. Even games have certain ports. So certain games you play might operate on a certain port to send data and information. Now, uh, the regular IP addresses is use IPv4. This is IP address version 4. Now, this has about 4.3 billion possibilities. Now, you might think, wow, that's a lot. Well, guess what? We're actually running out. So, they've developed IPv6. Now, what's so good about this IPv6? Well, IPv4 is 8-bit. So, this is a subnet. This is attached to every single IP address. There's three different classes, A, B, C, and D. Don't worry about that so much, but this is the important part right here. The subnet is what determines networks and how many hosts and how many networks can be on a single IP address. So we won't get too much into that, but if you're curious, I highly recommend you look into it. It's pretty interesting, and this is the core function of how a network is run. Now, IPv6 is 64 bits, which gives a huge amount of possibilities. It's if you look up the number, I don't even know if they have a name for it, but uh, basically instead of going through 1 through 0, you have 1 through F. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then A, B, C, D, E, F, and then with a few more spaces in between. So that's coming in the future. So I highly recommend too, if you're interested in networking, you look into this as well. Now let's take a more common problem. Like, let's say you're the IT administrator of the clinic. You have 8 hours in a working day and have 100 computers you need to image. It takes 4 hours per computer and you can do it 5 at a time. How long will it take to image all 100 computers? All right, so let's take a few key elements. So 8 hours, let's look at the numbers. 100 computers, 4 hours. Let's just look at this real quick. All right, so we know that eight, 4 goes into 8 twice, right? So with that being said, and we can do 5 at a time in a day, that means we can do 10 in 8 hours because 4 goes into 8 twice. We can do 5 at a time. So 5 times 2 is 10. And we have 100 computers, right? So 100 divided by 10. 10 goes into 100 10 times equals 10. So we can do all 100 computers in 10 days. Just, well, that's if nothing goes wrong. Also, remember, if you ever use something on the internet, like the scientific method picture I use, make sure you have a reference for it. You don't want to be using someone else's work without putting a reference. Imagine you made art or something and then someone used it without your permission and they give you no credit. Doesn't feel good, right? Well, I hope you enjoyed this and I hope it helped you understand how STEM might relate to an everyday job or practical life situations. Now, really consider this. Being an IT professional is great. If you like computers and you like fixing problems, problem solving, then it might just be for you. And consider this. I'm working all the way in Japan, which is a great pleasure to have. And maybe you want to work somewhere else in a remote site in the world. IT can take you there because everyone has IT needs. And there's plenty of American based companies that might need help overseas. So they need English speakers and people who are good with technology to work overseas. Or you could work for the military, like me. So enjoy and have a great day. Bye.